So here is another question on specific heat and calorimetry. It is given 0.2 kg aluminium block at 80 degrees Celsius is dropped in a copper calorimeter of mass 0.05 kg containing 200 centimeter cube of ethyl alcohol at 20 degrees Celsius. What is the final temperature of the mixture? Then some information, some data is given. Density of ethyl alcohol is 0.81 gram per centimeter cube. Specific heat of ethyl alcohol is 0.6 calorie per gram per degree Celsius, and then we have specific heat of copper is 0.094 calorie per gram per degree Celsius, and specific heat of aluminium is 0.22 calorie per gram per degree Celsius. Okay, so now let us try to understand what will happen. So this question is based on the principle of calorimetry, heat loss, heat gain, and the concept of equilibrium temperature. So the situation is something like this. Okay, so we have an aluminium block. Okay, it has a mass of how much? 0.2 kg. Okay, and it has a specific heat of 0.22 calorie per gram per degree Celsius. It is at an initial temperature of 80 degree Celsius. Now this block is taken and then put in a copper calorimeter. Which contains ethyl alcohol. So this is the copper calorimeter. It has a mass of how much? 0.05 kg, and specific heat of copper is given how much? 0.094 calorie per gram per degree Celsius, and then we have ethyl alcohol. The volume of ethyl alcohol is 200 centimeter cube, and the density of ethyl alcohol is given 0.81 gram per centimeter cube. So the mass of ethyl alcohol will be simply volume into density, that is 200 centimeter cube into 0.81 gram per centimeter cube, which is equal to 162 grams. This is the mass of ethyl alcohol present, and both the calorimeter and ethyl alcohol combination, the copper calorimeter and the ethyl alcohol combination, they are at an initial temperature of 20 degree Celsius. Okay, so when this block is taken and put in this high temperature block, this is the hot body, because it is at a higher temperature, so this is the hot body, the aluminium block, and this copper calorimeter and ethyl alcohol combination, it is the cold body. Cold in the sense it is at a lower temperature. So when these two are brought in contact obviously heat will flow from the hot body to the cold body because of the temperature difference, because 80 degrees Celsius is greater than 20 degrees Celsius. So this will lose heat and this will gain heat. Okay. Now as a result of this, aluminum block temperature will decrease and the copper calorimeter and ethyl alcohol combinations mixed, the whole combination temperature will increase. Okay, it will decrease from 80 degrees Celsius, it will increase from 20 degrees Celsius until they finally meet at an equilibrium temperature. Okay, in somewhere in between. This is called as the equilibrium temperature. So this equilibrium temperature, it will be lesser than 80 degrees Celsius, but it will be greater than 20 degrees Celsius. 80 degrees Celsius, which is the initial temperature of the hot aluminum block, and 20 degrees Celsius, which is the initial temperature of the cold copper calorimeter and ethyl alcohol combination. So we have to find this. Now let us try to determine the amount of heat loss by the aluminum block and the heat gain by the copper calorimeter and ethyl alcohol combination. So heat loss by the aluminum block. So here specific heat, this relationship mc delta T, this relationship will come into play because specific heat is given. So the heat loss by the aluminum block will be equal to the mass of the aluminum block, specific heat of aluminum block, and the temperature difference of the aluminum block, which is final minus initial. So mass of the aluminum block is how much? 0.2 kg. So we will convert it into grams because the specific heat information is given in terms of calorie and gram. So 0.2 kg, so 0.2 into 10 to the power 3 grams into specific heat of aluminum, which is equal to 0.22. Then here specific heat is given in terms of Celsius and also this temperature is given in terms of Celsius. So no problem, even though it was not given in Celsius and it was given in Kelvin, you remember change in temperature in Celsius is the same as change in temperature in Kelvin numerically. Okay, so here the initial temperature, higher temperature was 80 and the final temperature is TQ. So this is equal to 44 into 80 minus TEQ. Okay, this is the heat loss by the aluminum block. Then heat gain by the copper calorimeter and ethyl alcohol combination. So here also we'll use this MC delta T relationship for both copper calorimeter and the ethyl alcohol combination. So the heat gain by the copper calorimeter is mass of copper, specific heat of copper. So the heat gain by this copper calorimeter, it is given by this mass of copper, specific heat of copper, and change in temperature for the copper calorimeter. So it is equal to the mass of copper is 0.05 kg, so we'll convert it into grams. then specific heat of copper, which is equal to 0.094 calorie per gram per degree Celsius, and change in temperature. So the initial temperature is 20, final equilibrium temperature is greater than that, so TEQ minus 20, because equilibrium temperature is greater than 20 degrees Celsius. So then this is for copper. Then we have the ethyl alcohol, gain in temperature of the ethyl alcohol. So here it is, mass of the ethyl alcohol, specific heat of ethyl alcohol, and change in temperature of ethyl alcohol. So it is equal to mass of ethyl alcohol, we calculated, it is 162 grams. Specific heat of ethyl alcohol 0.6, and same change in temperature, that is TQ minus 20. So the total heat gain by the copper and ethyl alcohol combination, adding these two, we get 101.9 TQ minus 20. This is the total heat gain, and this is the total heat loss. Heat loss by aluminium, heat gain by copper and ethyl alcohol combination. Now, according to the principle of calorimetry, heat loss is equal to heat gain. Okay, this. So when we equate both these equations, we get 44 into 80 minus TEQ equal to 101.9 TQ minus 20. That implies, if we do it, 3520 minus 44 TQ equal to 101.9 TQ minus 2038. That implies TQ is equal to 3520 plus 2038 by 101.9 plus 44. Simply we have taken 2038 to the LHS side, 44 TQ to the RHS side, and we equate the result. So it is coming 5558 by 145.9 is equal to 38.094. So if we round it off, so 38.1 degrees Celsius. This is the equilibrium temperature, final equilibrium temperature. It is greater than 20 but lesser than 80 degrees Celsius. Okay, so this is the final equilibrium temperature. Okay, so this. So here is another question. It is given, calculate the difference in temperature between water at the top and bottom of a waterfall 200 meter high. The specific heat of water is given 4200 joule per kg per degree Celsius. Okay, so let's say this is the waterfall. Okay, so water is falling from a height of how much? 200 meters. Okay, this the vertical height from top to bottom. Let's say at any particular time MW, okay, this much kgs of water is flowing from top to the bottom. Okay, so when it is at the top, it has certain potential energy, this mw kgs of water, which is equal to mw g and h. This is the height. Okay, this much potential energy is there. So as the water flows down, this potential energy gets converted into heat, which is given by mw cw delta T. Okay, so here let's say there is an initial temperature Ti of mw mass of water at this top position. At the bottom position, here the temperature is Tf. So Tf will be greater than Ti, increase in temperature, because the potential energy gets converted into heat. Okay, this. So this we have to calculate. So here, according to the question, potential energy gets converted into heat of the water. Potential energy of water gets converted into heat. So mw g h is equal to mw cw delta T. We have to calculate this difference in temperature delta T. Our objective is this. So delta T, here mw will get cancelled out. So delta T is equal to gh by Cw, where Cw is the specific heat of water. So this is equal to, nothing is mentioned, so we'll consider acceleration due to gravity, small g, 9.8. Height of waterfall is 200. Specific heat of water, as per the question it is mentioned, Cw is 4200 joule per kg per degree Celsius, isn't it? Yes, joule per kg per degree Celsius. So it's 4200. So this difference in temperature between the top and bottom, it is coming around 0.467 degrees Celsius. So whatever the temperature was of the water at the top of the waterfall, okay, the final temperature is the initial temperature plus 0.467 degrees Celsius. This much increase in temperature happened when it fell through a height of 200 meters, because the potential energy got converted into heat. Okay, so this is the